Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshop and exercises to learn about AWS services. These workshop and exercises are published to our website aws-dojo.com. Some of my audiences talked about, say, if I can prepare one video and workshop for using relational databases with AWS-based data lake. So I thought, why not make one video where you learn how to use Amazon Redshift with AWS-based data lake. And of course, we have a workshop towards the end, which can help you get your hands dirty with this concept. So let's get started. Just to give you a very brief introduction, Amazon Redshift is a fast and scalable cloud data warehouse service from AWS. It can really handle petabytes of data. On the other hand, data lake is a central repository for all type of data, whether it's structured or unstructured. And data lake is supposed to be scalable to any size, scalable to any size. And in AWS, you use services like Glue, Lake Formation, and S3 to create data lake. And it is a very common scenario, guys, that you configure a relational database or Redshift as a data source to your data lake. Because when you talk about data lake, data not only sits inside S3, but you might also have data sources dispersed, but then they are accessible and discoverable from the centralized data lake. So it's a very valid requirement where you need to configure your Amazon Redshift database as one of the source into the data lake. And we are going to talk about that, but as I said earlier, that whatever principles, whatever methods and configuration we talk about is going to be pretty much applicable to any other relational database you configure as a data source within AWS-based data lake. Okay, so let's get started. So what are the steps required to do this whole configuration? And we will try to cover this whole tutorial under these 6 steps you see here. So first one is your relational database. In this case, okay, I'll try to not talk about Redshift more, but you now know that when I talk about Redshift, you can replicate those principles to any relational database you want to use. Okay, so your Redshift database should be in place, and you have to configure it in a certain way, and we'll talk about that. Then you need to create a database in your lake formation into your data lake, and then you need to configure certain permissions so that table catalogs can be created inside database. That's the second step. Third step is that you need to create some glue connection with the Redshift cluster so that components like crawlers can use this connection to catalog the data. Components like glue job can use this connection to work with the data, like manipulate the data, transform the data. Then you need a crawler, which basically crawls your Redshift database and registers as a catalog table in your data lake. And by cataloging your table into data lake, you are actually making your data discoverable and accessible through this catalog. Then you need to configure permission for these tables in data lake. So now you have cataloged your data into data lake. Now you need to define that which process, which user, which group should have access to this data, and that you can configure into your data lake. And finally, once you have done this step 1 to 5, actually your data is ready for consumption. You can use your reports into your data processing jobs to work with your data. So these are the 6 fundamental steps involved when you're trying to use a Redshift with data lake. So moving on to step number 1. So Redshift in place. So of course your Redshift, so like in this case, we are saying that if you're launching a Redshift, you will launch a Redshift inside a VPC in a private subnet. Yeah, generally you don't want your data warehouse to be publicly accessible, so you'll keep it into a private subnet. But in this case, our glue needs to have access to the Redshift. And for that purpose, we need to do certain configuration. Okay. So first, the configuration which we do is we define a security group. So we associate the security group which is associated with the Redshift. That security group should have certain configuration in place. The first configuration is that that security group should have a self-reference for inbound. So for inbound rules, for inbound messages, for inbound communication, it should have a self-reference for all TCP traffic. Okay, that's one configuration you need to do. And your outbound should be open to all destinations. So you need to have a security group like this defined and associated with Redshift. Because what will happen, your glue constructs like your glue job for data transformation or glue crawler for data cataloging, they need this security group based access to talk to Redshift. So they leverage this security group. And that's why this security group needs to have a self-reference access for all TCP ports. Okay, so this is one specific comment about the security group when you are launching your Redshift cluster into a private subnet. Again, applicable to any relational database you want to use here. Moving on. So once you have done this, then we need to, like your Redshift cluster is in place now. So this your step number is done. One is done. Now what you do is that you create a database in your data lake. So you go to lake formation and simply go and create a database. Now your database is created. And once your database is created, actually you will use crawler to catalog your tables, Redshift tables, as a data catalog in this database. Yeah. So suppose your Redshift database has got 500 tables. You might want to catalog those 500 tables into this data lake database so that people can come to database data lake and browse through the catalog and can see what data is available. And they can access it also in their jobs, in their reports that way. So in order to do so, we use crawlers to catalog your tables, Redshift tables, as a glue data catalog. But crawler needs to have access to the database. And for that, you create one IAM role for crawler. And this IAM role for crawler should have at least create table permission to be able to create table into the database, into the data lake database. Okay, so this is another specific requirements which you need to do. So the moment you create a data lake database, you create a role which is going to use by the crawler to have this create table permission on this database, so that when the crawler runs, it can scan the table inside Redshift database and can create corresponding catalog, data catalog for them in this data lake database. Okay, so that's the step number 2. Now, once you have done that, now you need to set up connection with the Redshift cluster. So now you need a mechanism through which your glue crawler or your development environment or your glue job can connect to Redshift cluster. So networking part we took care of here, right? When we set up the security groups, the network connection we set up. Now we need to set up this authentication, and for that authentication, you create a glue connection. So in glue connection, actually you tell, oh, this is the Redshift cluster I want to connect. So you give the connection string to the Redshift cluster. You provide the login name, password, and which you also select which subnet which VPC this Redshift is, which subnet this Redshift is in, and you also mentioned the security group we configured for Redshift, which you're going to use. So those things you provide as a configuration for glue connection. And then what happens actually that glue connection will simply leverage the security group which you have just created for Redshift, and it's going to create an ENI in the subnets you configure, in the subnets you selected, so that your connection can use this ENI to connect to the Redshift for the connection. Okay, so the purpose of the connection is pretty straightforward. It provides a method to it provides a mechanism to authenticate and connect with your Redshift cluster. Okay, and it stores the authentication information. It uses security group and ANI to find a network path, network connection to your Redshift cluster. Now, once you create this glue connection, it can be used in many ways. Yeah, it's really a multi-purpose connection. You can use it with your crawler, because crawler needs to talk to Redshift cluster to catalog the data. Of course, the crawler needs to use this connection. You need to use it with the glue job, because glue job needs to talk to Redshift cluster to either read data or write data back to the Redshift cluster. So again, it uses connection. And you can also use the developer endpoints, because before you write the glue job, actually you might want to write some script and test it out in terms of querying the data, doing some transformation, writing it back. You want to do those kind of testing, and that you can do with the developer endpoint and your editors, like for instance Jupyter Notebook, or you can also use PyCharm. And yeah, and even in that case, you need connection to connect. You need to use Glue connection to talk to the Redshift cluster. So Glue connection is really a useful thing here. Okay, so having set up the connection, now the first thing first, we need to catalog the table. So we got our Redshift cluster in place. We got our Glue connection in place. Now we need to create a crawler which simply uses this connection and talk to the Redshift cluster. And then all it does, it creates Glue data catalog. So in case of like relational database or Redshift, what it does that you can actually tell that which database you are interested in. You can also filter down in terms of table names if you want to. But basically, whatever you tell, it will simply create one-to-one mapping. So one table will map to one Glue catalog table in the data lake. So it will simply go and catalog the data. And with this cataloged data, actually now the end users of the data lake get a mechanism to actually understand what data is available in their data lake. That means it provides a way to discover your data. So, and second is, of course, you can also access your actual data using this data catalog. Okay, so once we have cataloged the data, so in this step we catalog the data. Okay, job done. Now, just because data has been cataloged, it doesn't give you access automatically. So now you have to work a bit on the governance part and say, okay, fine, my data has been cataloged. Now I need to provide permissions to this catalog. And this permission you can provide to a role for the job. So suppose you want to write some kind of data transformation job, and in that case, Glue job, I mean. In that case, you might want to create a role, and then that role will have permission on this Glue catalog. And of course, that role you will assign to the job. So the job also has permission to talk to the Glue catalog. You might want to use with Jupyter Notebook in case you want to do some development inside, some query inside Jupyter Notebook with this catalog. You might want to give this access to like your end users or to the groups. And users could be IAM users or any federated users. So you can provide access to your end users as well, so that these users can access this Glue catalog for their reporting or dashboarding purposes. So basically, these are different typical type of identities which you have to give permission to the Glue catalog. Okay, and so that they get access to the data. And a type of table permission you can provide is pretty much like CRUD kind of, like you can really, for reporting purposes, all you want is probably you want to give describe and select only. But if you want to literally do more things, I mean, you can also provide some alter or drop or insert or delete kind of permission as well. If you provide super permission, that you get a super permission. Yeah, you get all permission. You also have a choice to actually control access at the column level as well. So you can really say, okay, I want to give select permission on the following 3 columns only, nothing more than that. You can do that as well. But in this step, which is very important, now that we have got our catalog in place, that means this catalog is a way to find out what data is there in the Redshift, both from the discovery purposes as well as for the reporting purposes, as well as for the data transformation purposes. We need to assign permission on this data catalog so that the jobs or the notebooks or the reports which you want to run against this catalog have permission to access the data. And guess what, guys? After that, you are good because now you are ready to use the data because your data is cataloged, your data permission has been set. Now you simply have to use the data, and you can use it in. You don't use then data directly from Redshift, but you go via Glue catalog. So you can simply say, okay, I'm going to talk to Glue catalog, but through Glue catalog, actually you're talking to actual data source behind the scene. And that you can do inside a Glue job. That you can do inside a developer endpoint, like when you are doing developer into, say, you want to try out some script, some PySpark script or Scala script into, say, Jupyter Notebook or any other IDE, then you can simply talk to the Glue catalog, and Glue catalog will make sure will actually ensure a connection all the way back to Redshift to give you the access to the data. Okay, and in all these cases, again, this Glue connection comes to the place because your Glue connection is used by both job and developer endpoint, or even your, in some cases, reporting tool to talk to your Redshift cluster. Okay, so that's how it works. Now, I want to show a few things. In fact, I want to show some code snippet from the development point of view. So suppose, like in this method, I said that you can talk to Redshift, but you don't need to talk to Redshift directly. You talk through the Glue catalog, and Glue catalog kind of works as a proxy for your real data, right? Because in a central data lake, you have this whole catalog created, which represents the actual data behind. Actual data behind could be in Redshift, could be in S3, could be in RDS, but they are represented by their catalog into the data lake. So they're kind of proxy because they don't actually hold the data. The Glue catalog does not, data catalog does not hold the data, but it represents some actual data staying behind. But you can talk to the Glue catalog, okay? And I want to show you how do you talk to the Redshift data using Glue catalog in a PySpark code. So just to show you code, a few snippet. So when you're trying to access your data through Glue catalog, your Redshift data through Glue catalog, first you need to create a Glue context. And actually Glue context is created using the Spark context actually. So it's kind of a wrapper on top of Spark context, but then it enables you to talk to the Glue catalog actually. So by wrapping up the Spark context, Glue catalog actually provides you features and methods to talk to the Glue catalog. And you will see some of those features very soon. The second one, so once you have created the Glue context, then you want to read the data. In that case, you can in the Glue context, you can call this method called create dynamic frame from catalog. This is your data lake database. Remember that we created this database here? Yeah. This is the database name over here. This is your catalog table name. Again, this catalog table you created here. Yeah, here you created data catalog. Yeah? So this one is that table name here. And you need to also, in case of Redshift, provide a temporary directory, which is primarily used for the query purposes. And simply run this statement, and guess what? Now you have a data frame, dynamic frame in this case, which is actually providing you access to the data inside Redshift. Okay, so again, you can see here, you're talking to the data lake database, data lake data catalog, not to the actual Redshift behind the scene, but still you get access to that. So this is how you read data from the Redshift. Now, if I move on and see how you write data back to the Redshift, then, and of course, I'm not talking about the once you load this data into dynamic frame, you can apply n number of transformations. And I'm not covering that here because I have a separate tutorial and video which talks about how you can use PySpark for data transformation. So you might want to see that if you're interested in learning the transformations possible with dynamic frame. Okay, here I want to show just communicating with Redshift, nothing beyond it. So moving on to writing data to Redshift, and in this case, you can see here, we can again use glue context and say, I want to write dynamic frame, using JDBC. And then in this case, this is my dynamic frame, which I want to write back. This is my connection name, so same Dojo connection we created here. Yeah, remember this connection name. Now, in this case, we need to provide which database and which table we want to write, because now we are writing it back to Redshift altogether. In this case, we say, okay, my data table name is this, and this will be a table name here. So that table need not exist because you're writing data back. So if table does not exist, it will create table for you. And then you're simply saying that my database is this. So when you run this script, this particular line of code, what will happen is that the data into this dynamic frame will be created back into the dev database in the Redshift with the table name this. Okay, so this is how you write back the data, and again using data connection, using glue connection to connect to the Redshift. So this is how you write data back. Now, moving on, and so what we are going to build today. So what we're building today is that you will create a Redshift cluster, and you will use a crawler to catalog that into a Glue database catalog. Then we are going to create a developer endpoint. So I'm not going to create a Glue job. Again, if you want to learn how to create a Glue job, go and see my PySpark tutorial, and there I show you how to create a Glue job. But we create a developer endpoint, and then with the developer endpoint, we launch a SageMaker notebook. And with this SageMaker notebook, we will read data from the Redshift, we write data back to the Redshift, and we also write data back to the S3 bucket, just to show the completeness that data from one source can be written to the other source. Yeah, just to show that part, I just read data from Redshift, write it back to Redshift, and write it back to S3 as well. So this is what we are going to build today. In order to build this one, we have created a workshop, and this workshop has been published to our website, aws-dojo.com. What I'm going to do now is I'm going to walk you through the steps involved in this workshop, and I will explain what's happening there. And then post that, feel free to run this workshop by your own. You just need to follow instructions step by step, and you can implement the scenario we just talked about. So without wasting any more time, let me show you the workshop, and then you can run it by your own. So here's the workshop published to our website, aws-dojo.com. We have already discussed the scenario here, so we simply click on to restart the workshop. These are the various steps you need to perform the workshop. So it's a little lengthy, but yeah, fair enough, we will do that. So first one is that the prerequisite, which is you need to have an AWS account. And if you don't have an AWS account, click on this link over here to create the account. Next, you create an IAM role, okay? And in this case, we are creating an IAM role because this I'm creating one generic IAM role, which will be used by all the developer endpoint and crawler over here. So I will give that role permission on a database as well, permission on a table as well, to keep my job simple. So we are creating a glue role here, IAM role for glue here, which then will be used by crawlers or developer endpoints to talk to the glue catalog. And of course, this role will be given permission on the database and the catalog. So moving on, so you can, so you go to the IAM admin console, and then you say, I want to create a new role. You select glue as the service for the role, then simply give power your access permission just to keep it simple. And then we simply create the role, and the role name was Dojo Glue role. So my role has been created. Now what we do is that we are creating an S3 bucket. So remember, the scenario is that we want to write back to the S3 bucket. So we want to read from the Redshift and write back to the S3 to implement that part, we go to the S3 management console and we create a Redshift bucket. And this bucket we create two folders, data and script. So data I will use to write data back from the Redshift, and script I'm going to use it in my code. So remember when trying to read data from Redshift, I want to write data back to S3, I need to provide a bucket location for the temporary directory as a temporary directory. So I'm going to use this particular folder as that location. Okay, so I put it there. Okay, so what you do next? I'm launching a Redshift cluster. So, so simply go to Redshift management console. Say I want to create a Redshift cluster. I give this cluster a nice name. Those are Redshift, free trial version, just to keep the cost low. I put my database name as dev, my username, my password, and then we simply create the cluster. So by default, it is using a default security group. So I'm going to use the default security group with my connection. So that's why I didn't show it here. But basically, when you use the free trial version and try to use the minimum configuration, it uses default VPC and default security group. So I'm going to use default VPC and default security group when I'm trying to create my glue connection, so that my glue connection gets a network path all the way back to the Redshift. Okay, so now my cluster is ready. So what I will do is that I will use this query editor to connect to the cluster, and then again, this is a query editor provided into Redshift itself. So I use that to connect to the cluster, and then I'm simply going to create one table over here. So I don't laugh, guys, but I'm just going to create one very simple table, dojo table, first name, last name, age, and then I simply run a script to register 3 records into it. So I'm not creating a very big table here because my purpose is to show the connection. So I simply created this one table and 3 records into that table so that I can show you how you can talk to this database. So after that, we need to create a private link. So this is something I didn't discuss in my presentation part, but it is one of the technical requirements. So when you have when you are using with Redshift or any relational kind of database, then your VPC, your ENI has to talk to your S3 bucket as well. And in that case, you don't want traffic to go over internet. So there are two choices of so you want to provide a connection from your ENI to the S3 bucket. There are two ways you can do that. You can use NAT gateway. In that case, the communication will happen over internet. Or other way is that you can use endpoint. In that case, it uses AWS backbone to create a private connection to the S3 bucket. So in this case, we are creating S3 endpoint in default VPC so that when the ENI created by connection tries to talk to S3 bucket, it will simply use this endpoint to talk to S3 bucket privately. Again, other choices to using NAT gateway. So we go to the VPC management console, say you want to create an endpoint, and then you simply select which service, sorry, endpoint to which service, and you say S3. And again, it tells you which VPC, you say which route table, and I'm selecting a route table which has all 3 subnets involved so that I get connection from all the subnets. Full access, again, not the best access, but just to keep it simple, full access to S3 bucket, and simply we create the endpoint. Now my endpoint has been created. After that, we go and do the next step, which is configure the data lake. So we go to the AWS Lake Formation. First, it will ask you to add an administrator. You add the administrator. Then you go to the databases menu, menu, and say, hey, you want to create a new database. And in this case, you say, oh, my new database is DojoDB. And then you make sure that you uncheck this one, because all it is saying is that I'm not going to use this. This is to more provide backward compatibility with before Lake, even before Lake Formation, Glue was there, and at that point of time the access was through role only. But now in Lake Formation, you can define a permission which can actually overrule the role permission, or those kind of group permission. So if you uncheck this, then it ensures that whatever security permissions you define into the lake formation, that is the ultimate security permission going to be used by data access. So it's very important you uncheck this, but if keep it checked, it gives you backward compatibility, nothing more. So once you have done that, actually, your database has been created. Now, my database is created, but I need to use a crawler to catalog data. In order to do so, I need to grant. Remember, this created this role, which will be used by the crawler and anything else we want to work with the data. So we are going to give this role permission to this database. So we simply select this database and then say I want to grant the access, and then I say. I'm giving this role create and alter access to the database. Okay, so it can create objects and alter. So having said that, now my role has got permission to create a catalog table inside my database. Okay, so now what you're going to do is that we are going to configure the connection. Okay, so now role permission is granted. So we go to the Glue management console and say I want to add a new connection, and then you give this simply a connection name. I'm providing here the connection type as Amazon Redshift, but there is another choice called JDBC, and when you are using something which is like not RDS or not Amazon Redshift, then you might want to select JDBC as an option. In that case, you have to provide a connection string to your database. So in this case, since it is Redshift, so we use Amazon Redshift. And then on the next screen, you simply provide your cluster name, your database name, your login name, password, and you finish it. And then it's always a good idea to test the connection. And when test the connection, say, okay, which role I should use to test the connection? And then guess what? We already have a role for all these purposes. So we simply mention this Dojo Blue role, and then we simply run the test. And wait till you see that test has been successful, because that gives you confirmation that you are able to create connection to the Redshift clusters. So when the crawlers or glue jobs or your developer endpoint use this Dojo connection, they will also be able to connect to your Redshift cluster. Once I have done that, I'm going to create the crawler. Okay, so things are moving fast. So our connection is ready. Now we simply go to Glue management console and say I want to create a new crawler. You give this crawler a nice name and say, okay, what is your database data source? And say, oh, my data source is actually JDBC. Yeah. So here it becomes little okay. But tell me type of data source, and all the relational databases, including Redshift, becomes your JDBC type. You select the connection. So of course, you're talking to this JDBC, so you need to ask okay, which connection to use. I mean, so which particular database I'm going to talk. So that information it takes from the Dojo connection. Then you have to provide your include path. So you can see here I'm telling here it's dev and then this percentage. That means any table inside dev database. I'm interested in that. So here you can provide the filter criteria to decide what table, what database to pick, and what table under the database to pick. Okay, so you do that. Then I say, okay, I don't want to add another data source. Again, it will ask you the which role this crawler will use, and this is important here because we are using this Dojo Glue role. And remember, Dojo Glue role has permission to create table inside the data lake database. If you have not provided that permission, crawler will run, but due to no permission to create table inside the data lake database, it will fail to create. It will fail to do anything. Okay, so that's why we first provided permission to the database for this role, and now we are simply saying, hey crawler, go and use that role. So that will give you all the required permission. Now it tells okay which database you want to create this whole catalog, and say okay this is my Dojo database, and then you simply save the crawler, and once you have saved the crawler, you run the crawler. It takes some time to finish the crawler. Like in this case, it took almost 44 seconds. But you can see that at the end of 44 seconds, it has created a table for you. Yeah? You can see that table has been created. That means it went to the Redshift cluster, identified the table inside that, and simply cataloged that table inside my Dojo database. So you can see here, if you go to tables, you can see that your table has been created, and you can see the name here. It says database schema table name. Yeah, that's how it generated the name. So your database underscore your schema, which is public, underscore your Dojo table. Remember, this is the name of the table we created when we are setting up the Redshift cluster. Now my table is catalog. That means I can use this table either to report on data or to query or to use into my Glue job. I can do those things. So, but before I do that, I need to grant permission to this table. So who has access to this table? In this case, we are going to use, again, this Dojo Glue role. So one role we are going to use for multiple purposes. So this Dojo Glue role should have permission to this table. And since my purpose is to actually read data from the data from this using this catalog, so I simply want to give a select permission. So I said, Dojo Glue role, you have a select permission on this particular table over here. So we simply configure that permission into the lake formation. Now with that, actually, we are now good to actually write a job or using this role or write or go to your dev environment and write your script fetching your data. So in this case, what we're going to do is that we are going to actually create a dev environment using Jupyter Notebook. So in order to do so, we first get a set up a developer endpoint. So we go to next step and say in Glue, I want to set up a developer endpoint. So we say dev endpoint. I want to add a new endpoint. We give this nice name. And then again, it will ask, okay, which role this dev endpoint is going to use, and I'm going to use the same role here. Because this role now has access to the new data table catalog. It has select permission on that. So with this endpoint, actually, I will be able to make a select query to that table. And after that, actually, you go to the next step and they say, okay, do you want, what connection do you want to use? And again, you use Dojo connection. So by virtue of this, again, my dev endpoint will now have a network part to the Redshift cluster as well. Okay, because then it's writing data back, actually is going to write data back directly to the Redshift, and for that it needs to have a connection information for the Redshift, both at network level and at the authentication level, and that information is configured into Dojo connection. And then with that, we simply create our dev endpoint. So we finish the dev endpoint. It takes roughly 8 to 10 minutes to finish because it's literally setting up a dev environment for you. Okay, and once you have done that, you can launch your SageMaker notebook as your ID, as a place where you can write your code. So you simply select your dev endpoint and say, I want to create a new SageMaker notebook. In this case, you give this notebook a nice name. You simply say, I want to use this dev endpoint. And notebook needs its own configuration, so its own security permissions, and for that you simply say I want to create a new role, and it will use a template to create a role for this notebook. And we simply launch the notebook instance. Once we launch the notebook instance, we wait till the status change to ready, and then we are all good to actually start programming with our Redshift data using Glue catalog. Okay, using my data lake. So that's the next part. So you go to the next part where you select your notebook and say I want to open the notebook. It will open the Jupyter notebook interface. You say I want to create a new file and I want to use PySpark for the development. So you use that notebook type, and then it creates a new session for you using PySpark. As I mentioned in the presentation earlier, then you run this line of code over here to create the glue connection first. It's going to use the Spark connection, Spark context to create a glue context so that you have methods and features available to talk to glue catalog, talk to glue catalog and other glue features. After that, you you start the session. So it takes some time to start the session, but once session starts, you can see here that says, hey, my Spark application has started. Okay, so now my session is in place. That my blue context is created and is populated, is ready. It has a session created with my data lake. Now, in that case, we first run this line of code over here, where we simply say, I want to read data from this table, which is my catalog table, uh, from my database, and this is my temporary directory. Yeah, remember this directory, this folder, this bucket in this folder we created in the earlier step. So when I'm running this code to actually read data from the catalog, from the Redshift, and then I want to print a schema to see if I'm connected to the right place, and you can see that this is the same schema like the table created inside Redshift. But again, I'm not talking to Redshift directly, but I'm talking to Blue Catalog, and through that, I'm talking to Redshift here. In that case, we do that, and then I want to just show you a simple transformation. So I'm saying, okay, now I have got my Dojo DF as a dynamic frame created. I want to simply transform a simple transformation. Say I'm not interested in age over here, so just give me the first name and last name. So I created a small another dynamic frame saying give me a small dynamic frame where only first name and last name is there. There's no age over here. So I create that and I print that schema to see that yeah, it has got only first name and last name. Once I have done that, this data, this dynamic frame, now I want to write back. And first I want to write back to S3 bucket. And for that, we simply use this method over here. You can see here, we say glue context, write dynamic frame from options, and say this is my data which I want to write. I want to write to the S3, so my connection type is S3. And then I also provide my path where I want to write the data. Okay, so this is the data folder under this bucket where I want to write the data. And then this is my CSV format. Again, I can choose other formats like JSON or Parquet as well. So I run this line of code, and what's going to do that whatever this many dynamic frame we created over here, that data is going to write back to the S3 bucket here. Simply write to the S3 bucket. So once I have shown that how I can read from the Redshift and write to the S3 bucket, next step I'm going to perform is to write this data back to the Redshift cluster itself. So for that purpose, we go and write another line of code, which is glue context, write dynamic frame from JDBC connection, and then you simply say this is the dynamic frame I want to write. This is the connection I want to use. This is going to be my target table name into my Redshift cluster, and this is the database in my Redshift cluster. And I provide a temporary directory for my Redshift scripting. So when we run this code, actually, this data is going to create a table like this with this name in the dev database, and in that table, it will simply go and write this data over here. So this line of code is actually reading data from writing back to the Redshift cluster itself. So you saw another example where you're reading from the Redshift and writing back to the Redshift. Okay. Now you can go and check the data yourself. So for instance, if you go to the S3 bucket, you can see the data created by virtue of this line of code over here. Similarly, if you go to the query editor, actually you can see that if you go and make query to say select star from Dojo table mini, like this table name over here, you can see that first name and last name has been created over here as well. So this was an example how you can use Redshift with data lake, and how you can make query to the Redshift, how you can write data back to the Redshift, and what are the different configuration you need to work on in order to achieve that. Yeah. So next step is to go and clean up the resources so that you don't incur any cost post this workshop. So that was all for the workshop, guys. Hope you like it. And if you like, please click on like button and please subscribe to my channel. There are many other similar workshop and exercises which you can use to learn about AWS services. Please do explore that. If you have any feedback or comment or suggestion or request for new content, Either you can write us in the YouTube channel comment section, or you can also click on this contact us tab over here and can provide feedback from there. So we always look forward to your feedback. For the improvement for the content. That's all for today. I promise to come back again in a couple of days' time with some new content. Meanwhile, yeah, stay safe and have a nice day. Bye bye.